Hello guys, in this lesson we're going to be solving this cool problem. Well, this is an equation that has tetration in it. You'll notice we have an hyperoperation here. This hyperoperation here is tetration and it's it's different from the regular exponentiation. So we cannot solve this kind of problem using the method we would have used if this has been exponentiation. Well, how do we solve this? Well, let's get right into it. We have 4 here. 4 here can be rewritten as 2 multiplied by 2, which is 2 to the second power. But you will notice that 2 to the second power is the second iteration of 2. You can see we have a tower of 2, right? So we can then rewrite this as the second iteration of 2. While on this side we have the we have 2 tetrated to the second iteration of 2x. You notice that? So you will notice that on both sides now we have something similar. We have hyperoperation, similar hyperoperation on both sides of the equation. And so we can get rid of this part here, these 2 here. Then we equate the superpowers. The superpower we have on the right side is the second iteration of 2x. This bracket right here, this parenthesis right here is very important. So because it clarifies that everything here is tetrated to the second power here and not just this part alone. And all of this is equal to the superpower here, which is 2. Well, what does this imply? This simply implies 2x raised to 2x power. Well, that is what tetration is in the first place. So when a value is tetrated to the second power, it simply means you tower it twice, right? So we have 2 of them. If this had been 3, this would have been 2x raised to 2x power and raised to 2x power. If this had been 3. So I hope you get that. So on this side is equal to 2. Well, at this point, you will notice we need to make use of the property of Lambert W function to solve the problem completely. So, but before that, it's reasonable to introduce natural log to both sides of the equation, and such that we can make use of the property of natural log that allows us to bring this back here. So we have 2x and multiplied by the log of 2x, and it's equal to the natural log of 2. Well, there's the property of Lambert W function we want to make use of is that when you have an expression in the form x e to the x, if you take the product log of this expression, it gives you this part right here. Okay? So, and that is what we are trying to achieve here. So we wanted to rewrite this expression such that it is similar to this form. So, and how do we do that? When you have 2x like what we have here, it will be the same as taking the exponent of the log of 2x. When you take the exponent of the log of 2s, it's the same as 2s. So, and that is why I'm going to replace the 2s with that, the 2s we have here. So I'm going to put this down first. So I have the natural log of 2x. So then instead of putting on 2s, I would write e to the log of 2x. And it's all equal to the log of 2. Okay, so you will notice at this point that the expression on the left hand side here is similar to this form. So let me put a bracket there, introduce product log, okay, or Lambert W function. But I have to put it on both sides, like you know. So, and this expression is reduced into the log of 2x because the expression will be reduced to this, just this part right here of the expression. And that's the property of Lambert W function. So, and on this side we have the product log of the natural log of 2. Okay, we're almost done here. We just need to take the exponent of both sides. so that we can get rid of the natural log we have here, and this is reduced to x equals e to the product log of the natural log of 2. We finish it off by dividing both sides by 2, right? And s is equal to e to the product log of the natural log of 2 and divided by 2. And this is it. Well, thank you, and see you in the next one.